So, we're up to question 3, and we're talking about the heights of Year 12 students are known to be normally distributed with a mean of 165 and a standard deviation of 8. Remember, this is how they're going to mention it in the exam. They're not going to use x tilde n 165 and 8. They're just going to give it to you in a sentence. So we can write, so we're going to first of all just define our random variable. So we're going to say let x be the heights of Year 12s measured in centimetres. And so we can say that x is normally distributed with a mean of 165 and a standard deviation of 8, using our notation that we use. This can just be a helpful way to summarise what they've said in the question, so you've got those numbers handy. Now the question is, well, how tall is Theo if he is taller than 95% of all Year 12s? So if we go out here, and I'll put a line there, that would roughly be Theo out there. Because to the left of him, all the way down and off to infinity, he's got to have 95%. To the left of him, because he is taller than 95%. So there's got to be an area of 95% that is to the left of Theo. So how tall is he? Well, this is where we can use our calculator. So I want everybody to get out their calculators. And we're going to go to number 2, which is statistics. And we're then going to go to F5 for distribution. And we're still working in the normal distribution. Now, because we're not getting probabilities this time, but we're getting a value from a probability, it's kind of like an inverse process to what we were doing before. Which means we're going to pick this one, INVN, which stands for inverse normal. So F3. Now, the data we keep is variable all the time. There is no case in which you're going to have to use this data. The tail is either going to be to the left or to the right. Now what the tail means is, where is all the area that we're going to be putting in? And we saw on the diagram that the area is going to be to the left of the value we're looking for. So we're going to keep the tail as left. The area we had is 0.95. Our standard deviation was 8. And our mean, what was our mean? 165. Okay, thank you. So, we enter those values. We hit enter. And it tells us that Theo was 178.16, rounding to 2 decimal places. So, I can say Theo, well, potentially before I just write what his height is, it's good to just give a little bit of information around what I'm doing. Now, as before, I can't write what I put into the calculator. That's going to count for no marks. But I can do a little bit else. I can say the probability that x is less than or equal to k is equal to 0.95. K is Theo's value. So I can say therefore k is equal to 178.16. And so that just gives a little bit of information about what process I'm doing here. This initial step just shows that I understand it's an inverse normal problem. I understand what this 95% actually means, and I'm using that to find Theo's height. So I can say therefore Theo is 178.16 centimeters. Okay, any questions about that? You'll find that it is a fair bit of calculator work, but you've got to understand the question to be able to use the calculator. So don't just think it's all on the calculator. How tall is Louisa if she is shorter than 80% of all year 12s? Well, in this case, she might be down around there, but she's got 80% to her right, so she's shorter than 80%. So all the area above her counts for 80% of the whole population. So in this case, I'm going to say the probability that x is greater than or equal to k is equal to 0.80. So then we're going to go back to our calculator. We're going to say, well, in this case, my tail is right. So that's F2, and then I'm going to come down and put in 0.8. And then the mean and the standard deviation are going to stay the same. And so we get that that's 158.27. So K is 158.27. So therefore Louisa is 158.27 centimeters. If you ever want to know whether it's left or right, you can kind of think of these less than and greater than signs as an arrow. So the small, the one where it's going to a point is pointing to which way you're going to put your area. So here it's pointing to the left, so we put in the tail as left. Here it's pointing to the right, so we put in the tail as being to the right. Might help, or you can always draw a diagram like this. That can be a very helpful way of actually working out whether it's left or right. Okay. The times taken by students to complete a puzzle are normally distributed with a mean of 28.3 minutes and a standard deviation of 3.6. Calculate the probability that a randomly selected student took at least 30 minutes to complete the puzzle. Why don't you go through and do that? Find the probability that a randomly selected student took at least 30 minutes to complete the puzzle. Okay, all right. So, what did we get? Probability that it'll take at least 30 minutes. Sure? Yeah. We haven't got it yet. Okay, so this is an NCD problem. So if we go distribution, normal, NCD. So we're looking at more than 30, so we're going to go 30. And we're going to go, our upper is 1 times 10 to the 99. This is a probability, so this is not an inverse normal, it's an NCD. Now, our standard deviation was 3.6, and our mean was 28.3. So if I go through and calculate that, it's going to be 0.318. So the probability that somebody's going to take at least 30 minutes or 30 minutes or more is 0.318. Now, you'll notice that I've also defined what x is and given its distribution as well. You don't necessarily need to do that in every problem, but it is a really good idea to give this in each problem so we know what you're thinking the mean and the standard deviation is. So if you just write x is normally distributed with a mean of that and a standard deviation of that, it can actually be helpful to determine or to help the marker know what you're thinking. Now, out of 10 randomly selected students, 5 or fewer took at least 30. We want to know the probability that out of 10 randomly selected students, 5 or fewer took them at least 30 minutes to complete the puzzle. This looks very different, and that's because it's an entirely different problem. Notice now we are actually counting numbers of students. We're no longer measuring, we're counting. So we're actually suddenly going to switch into a binomial distribution. So I can say let y be the number of students that take at least 30 minutes out of 10. So in this case, y is binomially distributed. N is 10, that's our number of trials because that's our number of students. And then P, the probability of success, the probability that one student is going to take at least 30 minutes, but we've actually just worked it out there. Probability of success is one student taking at least 30 minutes. We worked it out in part A, and it's 0.318. So, out of 10 students, we want 5 or fewer took at least 30 minutes. So, we want the probability that y is less than or equal to 5. And that's going to equal, and we're going to go across to our calculator. We're going to go exit out of normal. We're going to go to distribution, and instead of going to normal this time, we're working in the binomial. We're going to go B, C, D. Our lower is going to be 0 because it's 5 or fewer, so we can go down to 0. Our upper will be 5. Our number of trials is 10, and the probability of success we worked out was 0.318. We go through and calculate that number, we get 0.938. So there's what, a 93.8% chance that 5 or fewer are going to take at least 30 minutes. So this idea of setting up a normal distribution problem, using a normal distribution to find a probability, then using that as the probability of success in a binomial distribution is quite a common one. You've got to expect that that's going to come up in a test and an exam. Now, within that, how do you recognize that it's switched to binomial? Because it'll go from talking about measuring things. So we started by measuring height, measuring time that students would take, and then suddenly we've jumped into counting the number of students. Counting the number of students can only be in whole numbers. It's a very strong hint that we've switched to a binomial. Okay, any questions about that?